What's a collection? Well, it's exactly what it sounds like. It's a group of things put together. It's a collection of items. When you're working with multiple items in Java, you should recall that an array could be used to store the items. So all programming languages have some sort of structure to handle multiple data items, such as an array. But there are limitations to the array structure in Java. For example, you'll recall that when you create an array, you have to declare the size of the array up front. So an array with 10 slots can only store 10 things. You can certainly change the things that go into each one of those slots, but you can't change the number of slots. So you can't put 11 things into an array whose size is only 10. It's a fixed size data structure. Once an array is created, the number of slots cannot be changed. So the creators of Java had to design more higher level data structures to make working with a collection of items easier. Lo and behold, the collections framework was introduced, which made it much easier to work with multiple items. So we'll start off by talking about the most popular collections framework class, which is the ArrayList. And the ArrayList is nothing but a resizable array. The underlying implementation is based on the array structure. So let's go over how to use the ArrayList. I'm going to define a variable called words, and its type is the ArrayList. And we need to instantiate a new instance of ArrayList. So this is how that's done. Hover your mouse here, and it's saying we have to import the ArrayList class from the Java utils package. So let's click that, and here is the ArrayList. Now notice you're going to see these yellow squiggly lines. Hover your mouse here, and it's saying ArrayList is a raw type, and it's asking us to use these angle brackets with some generic stuff. It's called parameterization. We're going to look at that afterwards. That's called generics. That's the second portion of this lesson. We're going to get into that shortly, but for now I'm just going to use it the way it's being shown here. So we have a variable called words. It's of type ArrayList, and basically think of this as almost like a regular array. You can put things into it, you can take things out of it. So if you wanted to add things to this array list, we could just do words.add, and then you can add whatever it is that you want. So let's add a word, for example, hello. Okay, and if I want to add something else, I could just do add and then put another word in there. So similar to add, they also have remove. So I could do words.remove, and then I give the index position that I want to remove. So if I want to remove the first index position, the data in the first index position, I would just put a 0, and that would remove the word hello. If I want to remove the second term, I would put 1. So the way this is referenced in terms of indexes, it's the same way as an array. 0 is the first slot, 1 is the second slot, and so on. So there are these handy methods that we can use to add things to this structure as well as remove things from this structure. Let me add some more things. I could just add the number 10. Okay, so right here, this is a string data, right? This is also string, but here we're adding an integer. Let me add another integer. I'll add the number 9, and then I can add a double as well. So notice so far there are no restrictions as to what can go in here. I'm putting in strings on one line, then I'm moving on to an integer, and then finally I'm adding a double. I could even add, for example, letter H. This is a character data type. So all of these yellow squiggly lines is somewhat of an ominous thing. You should be able to see through this and realize that we may have a problem when we take this data out of it, out of this structure. So to get the data back from one of these index positions, all we would have to do is do words.get and then give the index position that we want. So let's get the first item in the array list, and I'm going to assign it to a variable. Well, we know that this is a string, correct? So let's define a variable called string, and I'll just call it item1. Okay, but notice that we have a problem. There's a red squiggly line here. Hover your mouse and it's saying type mismatch, cannot convert from object to string. So it's saying that what we're going to get from this get method is going to return us an object. It's not going to return us a string. Even though we know that we put a string in here, it's going to return an object. So what we need to do is we need to cast this data that we're getting back from it to a string data type, and only then we can assign it to this variable called item1. So this could be problematic. This doesn't really, this is not a very useful data structure. As you can already see so far, the way I'm implementing it here, I would need to know the data type at every single index position, because later on when I get that information, I would need to know the data type to cast it to store it in a variable. So this is not very user friendly at all so far. So let's get something from the second index position. I could do words.get and get the second index position, which is going to have the number 1. That's the second slot. And let's assign this to an item2 variable. And again, we would have to cast it. We need to cast it with a string, because the data that gets returned from this method call, it's going to return an object. As a matter of fact, for each one of these items in here, it's going to create an object, because an object is the parent for every single data type in Java. Object is the granddaddy of all objects. So strings, doubles, floats, everything is an object in Java. Any of your classes that you create, the classes that we've created in the previous courses, such as car, vehicle, animal, those were all children of the granddaddy, the object class. So the way this is handling it is everything that is put into words is going to be treated as an object. So later on, when we need to get it out, it returns it as an object. So we have two options here. I could either take this string and put it right before the words.get1, or instead of casting it specifically, I can make item2 be an object. Okay, because what gets returned here again is of type object. So you may think, oh, it's not a big deal. I could just make everything an object, right? Let's get rid of this string as well. Since it has objects in there, we'll just pull them out as objects and then use them the way we want. Well, let's get two integers. For example, this integer right here, the number 10 and the number 9. And that's the index position 2 as well as 3. So let's get 2 and 3. That's going to give us 10 and 9. Item 1 is going to have the value 10, and item 2 is going to have the value 9. And now let's try to add these babies together. So I could just do item 1 plus item 2, and there we go. We have a problem. It doesn't know what we want to do. What does adding mean here? These are two objects. Even though we know that these are integers, it's giving us a problem. We can't really add these two things together. We need to specify the exact data type. Right? It's saying the operator plus sign is undefined for the arguments object and object. So you can see that we're starting to see problems here. We know we can add both of these integers together, but because to get the data back out of the words array list, we're forced to treat them as an object. So what we're going to have to do is change it here to an int data type, and then out here we need to cast it to an integer. And now it's forcing whatever we get from the collection to an int, and then assigning it to item 1 and 2. And now we shouldn't see a problem. So hit play and notice that it was able to add those two numbers together. We get the number 19. Because Java is a type-safe language, it forces the programmer to plan accordingly in terms of data types. And this is crucial in the Java programming language. Java is a type-safe language, meaning that it forces the developer to know on every single line what data type a particular value is. All right, that information should not be hidden somewhere. It should be immediately available, visible clearly to the developer what every single value, what data type it should be. And this ensures that there are no data type issues during runtime. The errors could be caught while compiling, during compile time. Right now when we're coding, these are compile time errors that we see, these red squiggly lines that appear. This is a compile time issue. We haven't run the application yet. The Java compiler is complaining that, hey, this code doesn't make sense to me. So type safety ensures that the developer doesn't make any mistakes whatsoever in terms of data types. So it forces us to make sure that we cast the object that's coming out of the array list to the particular type that we are trying to assign to. Over here, it's forcing us to convert it into an int. And this is actually how the ArrayList was used before Java 5. Java 5 introduced the concept of generics, and that made dealing with collections a lot easier and much more practical. So the best way to handle this is, for this words ArrayList, I better only put one particular kind of data type. I can't put multiple kinds of data in there. I got strings, I got integers, doubles, character. I can only put one kind of data in here. And since Java is a type-safe language, they needed a way to enforce that rule. So how could we do that? Well, we already have the data type of the actual collection, right? How could we force that only a particular kind of data is stored in this collection? They came up with this syntax with brackets. And inside of these brackets, we could put the kind of data that we want to put in there, string. And over here, we need to also specify string, and I'll show you a shortcut later. But basically, now this words collection, this words array list, can only store strings. Notice that all of these adds method calls are erroring out. And the reason is we're trying to insert an int into a words array list that is only accepting strings. So we can only put strings in here. If I change that to the number 10 with string, it's going to allow it to work. So let's get rid of all of this. And now this is of course not going to work. Let's get rid of both of these. So to get the data at a particular index position, we want to make sure that we assign it to the right data type. So the data that's coming out of this words array list is going to be a string. Instead of int, I can just do string. And now this is compiling up to this point, and I can just print out whatever it is that item 1 contains. So that's gonna be the number 10 in the string data. So that's what we get down here. Right, so that's the introduction to generic collections. Without these angle brackets, we could still use the ArrayList collection, but it's far more useful to have this type safety here. Java 5 onwards introduced this templating, the ability to template your types. It's called parameterization, which is just a fancy term to enforce only specific data types going into collections. So ArrayList is one kind of collection. There are others that we're going to take a look at in this course. There's something called the linked list, and it works exactly the same way. We specify the kind of data that this linked list is going to contain. I'm just going to call it numbers is equal to new linked list, and that's how that's going to be initialized, almost exactly the same way as the ArrayList is initialized. So notice that there is an error. If you hover your mouse over this X mark, it's saying syntax error, insert dimensions, right? And this is just a fancy error. All it means is we cannot put primitive data types into these angle brackets, right? We need to force a reference type in these angle brackets. So basically anything that has a class. So this int primitive data type does not have a class associated with it. If you press the command key and hover your mouse over this int primitive, there's no data, there's no class that's associated with it. If I hover my mouse on this string, there is a class associated with it. If I click it, notice it takes me to that class. So only complex data types could be inside of these angle brackets, not primitives. So to get around that, we have this wrapper classes called integer, right? And this you can put, and it's going to work just fine. All right, hover your mouse over the integer class, and it's saying that integer class wraps a value of the primitive type int in an object. Okay, that's all it does. It, of course, it has a lot more advanced functionality, which you don't have to worry about too much. Just think of this as an int, okay? And it's just a complex class that surrounds the primitive int data type. So similar to integer, there is other wrapper classes such as double. Okay, we can have floats. Okay, notice all of these are compiling. I cannot use the primitive float data type, right? Notice the keyword, it's in purple. it's not going to allow me to use the primitive float. I need to use the actual wrapper classes float. Okay. Now the linked list here is of course erroring out. It's saying import the linked list class. So let's click on that, and that imports it up here. Both of these belong in the java.util package. So let me change this back to an integer, this as well. And now inside of numbers, if I do numbers.add, I cannot put some string information in here. It's going to error out. Hover your mouse and it's saying the type method integer. That's what's allowed in here, and we're trying to put in a string. So we need to put in an integer. So let's put the number 100, for example, and now it's going to compile just fine. So I'm just going to copy paste this a couple of times and put in some different numbers in here, 200, 45. And let's just put something else in here, 1000. So here we have a numbers linked list. It works exactly the same as an array list. Notice the way, we're using the add, and it has also remove. The only difference is the underlying data structure that's been implemented for the linked list. The array list is basically using an array in the implementation, whereas the linked list is using node objects. And not important to go over the details of how the linked list is implemented if you're new to data structures. If you want to know more about the linked list and how it's implemented underneath, you can take my course, Practical Data Structures and Algorithms. That's also available on jobreadyprogrammer.com. But basically, the array list is a resizable array, and a linked list is a bunch of nodes that are linked together. The idea is the same. They're both lists. Their implementation, the underlying implementation, is different. So I've added a couple of these numbers in here. If I want to loop over these, I could just give a for each loop. And it's just going to be int number, and numbers is the thing that it's going to be iterating over. This is going to be the value, the variable that's going to iterate over numbers, and I could just print out whatever number equals at every iteration. So let's hit run, and notice that it's printing out all of the values from 100 to 1000, from here down to 1000 are being printed out. So I just wanted to show you that you can use this for each looping mechanism to iterate over the collection, the linked list as well as the array list. Now I want to take a few moments to go over the difference between the array list and the linked list, how it's actually implemented under the hood. The array list is a resizable array, but you might think, hey, arrays are not resizable. When you create an array, you can't change the number of slots, and you'd be right. But the way that ArrayList is implemented is the default starting size of the array is 10 slots. That's the underlying array structure that's used. As soon as we try to put 11 items into it, what it's going to do is it's going to double this. It's going to create a new array. Instead of size 10, it's going to create a new array of size 20 and copy over all of the elements that are in the older array, the 10 slots. It's going to copy over all of those items into the new 20 slot array. And it basically enhances its size like that. So when you get to 19, 20 items in there, you try to insert the 21st item. At that point, what it's going to do is going to double the existing size of the array. So instead of 20 slots, it's going to create a new array with 40 slots and copy over all of the 20 elements from the older array into the new larger array, and then bring in your new item. So it's resizable in that manner. It basically continues to double the size of the array as you put more and more and more things into the collection. The linked list, however, is different. It has sort of a like how you have a train, you have the different box carts connected together with links, and that's exactly how I want you to envision this linked list data structure. When you need to add more data, all it does is attaches a new cart at the end of the train and continues to do that the more data you add into it. It's pretty dynamic. So the linked list data structure is actually better for manipulating the data compared to the array list. You see, when you want to remove something from the beginning of the array list, all of the items that follow need to be copied back to the 0th index position, back one slot over. The linked list uses something called a doubly linked list data structure, which you can review in my Practical Data Structures and Algorithms course to get those details. But basically, the linked list is faster for manipulating. And the ArrayList is faster for retrieving data. To retrieve values from a linked list, it would have to be traversed completely to find the particular element, whereas an ArrayList, much faster retrieval. You just give the index position and there is no traversal. It just immediately goes to the particular slot and gives us that data. So linked list is faster for manipulation but slower for retrieval. The ArrayList is faster for retrieval but slower for data manipulation, because you'd have to create new arrays as you add data. If you want to get more details of the linked list data structure, you should definitely focus on that after you're done with this course. Take the practical data structures and algorithms course, and that will help you understand the underlying implementation of the linked list structure. But both of these data structures, they're used in a similar way, adding and removing items. For example, if I do numbers dot remove, and you have a couple of options here. You can remove first, that's going to remove the first item. Remove at a particular index position. If I want to do that, I can remove at, for example, 0, 1, 2. Let's remove at the second index position. Hit play and notice that the 45 is gone. You don't see the 45 here. Similarly, you have words dot remove, and you can remove all. You can remove at a particular index position, but it doesn't give you the option to remove first. So there's slight differences in the different methods that you can use for the linked list and the ArrayList, but they work pretty much the same way. If we just use remove, what do you think is going to be removed from this set of data? It's actually going to be the first one that was inserted. So this 100 is going to be removed if I use the dot remove method only. So let's hit play and notice that that 100 is removed. We only have 200, 45, and 1000 left. Hover your mouse here and saying retrieves and removes the head, first element of the list. So this was the first thing that was attached to the train. The second thing was attached to the train. The third thing was attached to the train, and then finally the fourth one. Well, the remove method removes the first thing that was attached to the train, okay? And that's why that's the first thing that is removed. You can also do remove first. Hover your mouse here and it's saying removes and returns the first element from this list. So that's going to actually be the same number up here, this 100. Let's hit play and notice that 100 is removed. So remove and remove first do pretty much the same thing. So play around with these data structures. We covered a lot of ground. We talked about the parameterization. This forces a particular kind of data to be inserted into this ArrayList, and same thing here. Java is a type-safe language. That's why we need these parameterized types. We want to make sure that what goes in a particular collection is of the same data type, so that the programmer knows exactly how they're using a particular collection. Because without these parameterized types, without forcing the integer or forcing the string or any other data type, the programmer can make the mistake of putting anything they want into a collection, and that could get pretty hairy in terms of coding, as well as errors that could pop up. So when they designed this collections framework with generics in Java version 5, they warned all developers from using the old collections approach that I showed you earlier in the lesson. You want to always make sure you have your parameterized types when you're using collections. The ArrayList, we specify that, hey, only a string can go in here. In the linked list, we're specifying only an integer can go there, and these have to be data types associated with classes. We cannot have primitive data types in these angled brackets. We need to have complex data types. In other words, types that are associated with classes or interfaces, etc. And this is all just there to help the programmer better organize their code. So although this angled bracket syntax may sound or look a little confusing at first, the more practice you get with this, you're going to thank the Java community for introducing it, because it makes programming in Java much more pleasant, especially when you're using collections. Alright, so this lesson is already quite long. I'm going to wrap it up here. I'll see you in the next lesson. Thanks for watching.